Hi everyone, what's up? Today I want to show you how you can derive the point normal form of a plane if you're given 3 points contained in that plane, okay? So now this is going to be a broad strategy or a broad approach to deriving the point normal form. There are really a lot of ways in which you can derive this form, and you can show that given 3 points or given 1 point and the normal vector to a plane, you can connect piece of information to get an equation for that plane, okay? So today I just want to show you that if you're given 3 points within that plane, you can find the equation of the plane, okay? So let's start. So first I'm going to have a picture of this situation. So say we have a plane that looks something like this. Say we have this, and yeah, something like that. Yeah, this is going to be a plane. So say we have a point over here, and I'm going to label that point, let's call it P1. How about that? Pretty creative. P1. And now say we're going to have another point. Where should I do it? I'm going to do a point over here. This point is going to be P2. So this one will be P2. And let's say we have another point up here, which is going to be P3, okay? So this will be P3. So now we have the 3 points in our plane, okay? This is going to be a plane, and we want to find the equation of this plane in space. And the first thing that you want to do is you want to have vectors, okay? Remember, vectors are going to be our best friends here. And if you have 3 points, you can have two vectors, okay? So I'm going to say that P1 will be the origin. So we're going to have this vector over here, this vector from P1 to P3, and this vector here from P1 to P2, okay? We have two vectors. Now, this is the line of reasoning that we need to follow. Say that we have a fourth point, okay? And let's say that that point will give us the following vector, which will have a head here. And I'm just gonna call this point. I want to call this point just P. And P will have coordinates X, Y, and Z, okay? Now, really what we're doing here is we're just trying to account for for the moment in which we have a point that is not I want to call it like the pre-problem information. Before you start doing the problem, you're given information. But there's going to be, if you want to have a general solution for this, if you want to have a general point normal form, you need to have an XYZ solution. You need to have a solution in terms of any XYZ. Okay, so what we're doing here is we're saying, okay, we have 3 points. Now, what if we have another point, which is going to be XYZ, and it can be any XYZ. And then, given this point P, well, we can create a vector from P1 to P, okay? So now we have these three vectors, okay? So now with these three vectors, well, we can do really nice things because we know, so remember, this is something probably that I should really stress. P1, P3, and P2, they have known coordinates, okay? We know what their coordinates are. So anytime we use these numbers, where you multiply, I don't know, you take a dot product or something, you will have information, okay? So you're starting, with something to play with, okay? So yeah, this is assuming we know P1, P3, and P2, okay? We know its coordinates. So now, this is the line of reasoning we need to follow. If we have this P point here, which will have general coordinates xyz for any xyz in space, then we know there will be a relationship between a vector that will be normal to this plane and P, okay? Now, what do I mean by a vector normal to this plane? Well, normal in math just simply means that it's orthogonal or 90 degrees or pi over 2 radians. So if you have a plane, this is something that you just simply need to understand. It is very helpful to know what vector is perpendicular to that plane, okay? So say this board is a plane, any vector, a vector perpendicular to that plane would be a vector that is just simply pointing straight into that wall, okay? So you have a plane, and this marker, if this marker was a vector, it would be the normal vector to the board, okay? So that is the notation or the terminology we use. So now any plane will have a normal vector, so it makes sense to create a normal vector in this diagram, and I'm just gonna say it's gonna be something like this. Okay, this will be a normal vector. You will have a 90-degree angle with respect to the plane, and This is something very nice, and it's very nice reasoning. If this normal vector, which I'm gonna label as n, capital N, so if n is perpendicular to the plane, and the plane is parallel to P1 to P3 and P1 to P2, to these three vectors, or these two vectors, since the plane is parallel to these vectors, then the vectors must be perpendicular to n. Okay? So, well, how can I give you an example? So over there behind the camera, there's a wall. This board is parallel to that wall, which means that the normal vector of this board will be parallel to that wall over there. Will be perpendicular, I'm sorry. This normal vector, the marker, will be parallel to that wall over there, okay? Because that wall is parallel. Well, did I say that right? This marker will be perpendicular to that wall over there, because that wall over there is parallel to this wall or this board over here, okay? Hopefully you can visualize that. In essence, really, when you say that you have two things that are parallel to each other, try to think of them as one thing, really. So if you have a wall here, well, that wall over there is the same thing, okay? You just have a wall and you just moved it from one place to another. The normal vector will still be perpendicular to that plane, even if you have it here next to the board or behind the camera, okay? That's kind of how you can think of it. So now we will use the reasoning here. So if n is perpendicular to all these three vectors in the plane, there is a way in which we can create a really nice equation, okay? We want to create an equation because really the point normal form is just an equation, okay? So we can create an equation like this. If you take the dot product between n and any of these three vectors, you will get 0, okay? So for instance, if you do n dot p1, p3, well, this will be 0, okay? If you do n dot p1 to p2, this vector, this will also be 0, okay? Because we know that n is perpendicular to all of these vectors, so to p1, p3, and n is also perpendicular to p1, p2, okay? These are facts. And now how can you use these facts to actually get an equation? That's where this xyz point comes from. Well, we know that p1 to p3 is going to be a known vector because we know the coordinates of p1 and p3. And assuming that, we're going to have, I can call it a user, if you do computer science, when you have an equation, really you have a user of the equation. Someone will be using that equation. So I'm going to phrase it like this. The user of the point normal form equation that exists in math, the user will give us xyz point to play with, okay? And therefore, well, it also makes sense to create this equation, okay? Because we know we can prove that this equation is true because we know the coordinates for p1 and p2, and something I forgot to mention, we also know the coordinates of n. N is just simply going to be equal to p1, p3, cross p1, p2, okay? So really, you have two vectors that are contained in a plane, p1 to p3, p1 to p2. If you take the cross product between them, you're going to get a vector that is normal to the plane that is created by these two vectors. And we know that plane, well, that plane will be perpendicular to n, okay, which is a normal vector of the plane with these two guys, which is the same plane that we're dealing with here, okay? And since we know the coordinates for p1, p2, and p3, we can find the coordinates for n, okay? The components for n. I'm just going to say that n has components. Let's use some nice notation. Yeah, I'm actually going to use A, B, and C, okay? This notation works. So let's say this is the A, B, and C will be known constants, will be known numbers, okay? So that's something I should mention, because now, well, something we can do is the following. As I was saying before, using the same reasoning, well, we can do the following. We can say that we will have n, so n dot p1 to p, so p1, p, this will be equal to 0, okay? Now this equation is very important. This equation is absolutely key. This is where we will get our information. Because what is this equal to? Well, we know this will be equal to, so n, what is n equal to? We already have some components. Remember A, B, and C, there will be numbers that you know, okay? And now what about P1 to P? Well, we will be given coordinates for P1, okay? So I'm just gonna say that over here, yeah, I'm just gonna say it down here. Let's P1 be, let's just use X naught, Y naught, and C naught, okay? So these are numbers that you know about. You will be given these numbers in the problem. So you will have ABC dot X naught. Well, oh, sorry, I forgot something here, and that is we're not doing, this is really not a vector, but the beginning, the origin of a vector, the vector P1 to P, well, what is that vector going to be equal to? So P1 to P, we know it's going to be just subtracting the coordinates of the head and the coordinates of the origin. So this is just going to be X minus X naught, comma Y minus Y naught, comma C, or Z, minus Z naught, okay? I don't know what you prefer, C or Z. Kind of prefer C, it's easier to pronounce. So yeah, you're gonna get this. And you know that this dot product will be equal to 0, okay? Because we know that n, so how am I gonna write it? Yeah, we know this is equal to 0, so this will be equal to 0. Where should I write it so it doesn't look that ugly? I'm gonna do it over here. This will be equal to 0 because n, yeah, so it's 0 if and only if n is perpendicular to P1P, okay, to this vector. And we know that is true because n will be equal to the cross product between P1 to P3 and P1 to P2, okay? So this is true, therefore this dot product will be equal to 0, and now you can just use the series formula for the dot product. So the formula in which you multiply the corresponding components, basically. You have the sum from I equals 1 to n, if you have n dimensions, A sub I times B sub I, okay? And you can use that formula here, and we're gonna get the following. We're gonna get that n dot P1P will be equal to, so A times X, so A times X minus X naught, plus B times Y minus Y naught, plus C times C or Z minus Z C naught, okay? And we know this equals 0. And this is the famous point normal form that you know about, okay? So A, B, and C, they will be the components of the normal vector to the plane. And X naught, Y naught, and C naught will be any point that you were given, okay? So really P1 here, it can be anywhere, really. You kind of really don't have to think about you don't have to think about P3 and P2 as long as you are given P1 and A, B, and C, okay? Because then you can just simply use this formula and you can just simply plug those values in and you will have a plane. So I don't know, you would get a plane of this form. You would just get like 0 is equal to 3 x minus 1 plus 4 y minus 0 if y not equals 0, minus 2 times c minus let's say minus 1, okay, c minus 1. And now what would be the equation of this hypothetical plane I just came up with? So in this plane, the cross product between P1, P3, P1, P2 would give you a normal vector with components 3, 4, and negative 2, okay? A lot of times you will just be given n, and you won't know anything about P3 and P2, but sometimes you will be given 3 points, which is really what we started with, and you're supposed to use this reasoning to get to the equation of a plane, okay? So if you have 3 points, you just need to find a vector from P1 to P3, then find a vector from P1 to P2, take the cross product between those two vectors. Now you have the normal to the plane, and now you just need any point, any x naught, y naught, and c naught. It can be any point contained in the plane, okay? And then you just you get the components of n, you put them here, you get the coordinates of the point, you put them here, and that way you don't have to derive this entire thing and use this long line of reasoning, okay? But yeah, this is pretty much how it works, okay? This is very nice. I think this reasoning is very cool. Hopefully, well, now you see where the point normal form of a plane comes from. This really just relies on the fact that the dot product between perpendicular vectors will be equal to 0. If this was not the case, then we would get a constant here. And I guess it could also work, if it was like a well-defined constant, yeah, instead of 0, we would just have, I don't know, a constant k. And then, as long as you have A, B, and C and a point in the plane, then you would just simply get another constant on the other side of the equation when you distribute the coefficients into the point coordinates, okay? So yeah, that's kind of how you would go, yeah. So this is very nice, this is very, very important. If you're doing multi-variable calculus, this will definitely come up. So yeah, learn this, okay? So yeah, that's been the entire video. Hopefully you enjoyed it, and bye.